नमस्ते, गुड मॉर्निंग, गुड आफ्टरनून, गुड इवनिंग। दिन के जिस समय भी आप इस वीडियो को देख रहे हो, आप सबका इस वीडियो सेशन में हमारे यूट्यूब चैनल पर स्वागत है। There has been a constant demand from students about various chapters which we cannot always meet up because there are so many topics in physics and students keep demanding different topics, but that's the reason we thought of starting with a diversity of topics, that some topics of every chapter will be initially uploaded, and the aim is to ultimately cover up most of the part of 12th standard syllabus. So today we are going to speak about wave motion, sound waves. What exactly is wave? If I want to know, we have defined what a wave is. Wave is a mode of transfer of energy from one point of the medium to the other point without actual migration of particles. Energy will be transferred from one point to the other in the medium, but particles will not actually migrate. Only particles will be vibrating about their own mean displacements, and only the energy will be given to the next and next particles. So when I talk about such particles being present, I am actually speaking about mechanical waves. Now, what do I mean by mechanical waves, and what are the other type of non-mechanical waves? The mechanical waves are all such waves which need some kind of medium for their propagation. For example, we are speaking something, people are able to hear that, it's a kind of mechanical wave. The particles of medium, they are actually vibrating, air, they are vibrating, and they are receiving the receiver. The energy, sound energy is received. Whereas the other, you see, even the waves on the stretched wire or a stretched string, they are also mechanical type of waves. Whereas electromagnetic waves are those waves which do not need any medium for their propagation. Say for example, heat, light, radio waves, gamma rays, they are all electromagnetic waves. In electromagnetic waves, what is in fact happening is electromagnetic waves, in that you have got an electric field and magnetic field. They are both vibrating at right angles as shown in this particular figure. So you see, electric field is vibrating in one plane, the magnetic fields are vibrating in the plane perpendicular to that, and the propagation of energy takes place in some other third direction. So it's like x, y and z, that kind of thing you are having. Whereas one needs to understand that electromagnetic waves are having transverse kind of nature. Transverse means that vibrations are at right angles to the mean position, whereas mechanical waves, in which you actually need medium and the particles of the medium for the propagation of waves, these waves, they will be classified into two types. The first, we have said them to be transverse type of waves. The other are called longitudinal type of waves. Now, what are transverse? We have given them in the form of, you see, comparison. The first point of comparison is that in case of transverse waves, the particles of the medium are going to vibrate perpendicular to the direction of propagation. Whereas in case of longitudinal waves, the particles of the medium, they are vibrating parallel to the direction of propagation. Now, transverse waves, they are doubly periodic. It means they are periodic in space and time both. What do I mean by periodic in space and periodic in time? Even longitudinal waves are also periodic in time as well as in space both. What I mean by this is that when transverse waves I am speaking about, after regular interval of space called as wavelength, the particles will be repeating their phases, or they will be repeating their positions, whereas they will be in the same state of vibration. Whereas after a regular interval of time called as time period, the particle will again come back to the same position of vibration. So this is space periodicity and time periodicity. Then if you want a transverse wave to pass through a medium, the medium must have elasticity of shape. The medium must try to regain its original shape. Whereas if longitudinal waves have to pass through a given medium, the medium must be elastic in volume. Shape elasticity is not required, volume elasticity is required. Whereas now I find that elasticity of shape is possible only in case of solids and only in case of surface of liquid tries to maintain its horizontal level. So transverse waves can pass only through solids, or they can travel only on the surface of liquids, whereas every, let the, you see, medium be solid, liquid or gas, the volume elasticity is always there. All media are elastic in volume, and that is why transverse longitudinal waves, they pass through all solids, liquids as well as gases. Whereas now if I talk about the reflection, refraction, in case of transverse waves can be reflected, they can be refracted, they can be diffracted, as well as they can be polarized. Whereas in case of longitudinal waves, the longitudinal waves, they can be reflected, refracted, diffracted also, but not polarized. This is a major difference. For polarization of waves, waves have to be basically transverse in nature. Longitudinal waves cannot be polarized, and that is why sound waves cannot be polarized. Whereas the other transverse waves, they can be polarized, reflected, refracted, diffracted, everything can be done. The medium, whenever transverse waves are passing through it, that is divided alternately into crests and troughs. Whereas in case of longitudinal waves, the medium is alternately divided into compressions and rarefactions. Now, if I take into consideration one complete crest and one complete trough, that together will form one transverse wave, and in case of longitudinal waves, one compression and one rarefaction, that will form one longitudinal wave. Whereas if I talk about the speed of transverse waves, it's given by v is equal to root of t by m, or it's equal to root of y by rho. Whereas the speed of longitudinal waves in a medium is given by v is equal to root of e by rho, where e happens to be the volume modulus of elasticity and rho happens to be the you can say density of that particular medium. In case of transverse wave, when I wrote this formula v is equal to root of t by m, in that case, that v is equal to root of t by m, we were having T as the tension in the string and small m was the mass per unit length of the string. If you try to understand what are the examples of transverse waves, the examples of transverse waves are, you see, waves on a stretched wire or a string, and example of electromagnetic, you see, example of sound waves are basically longitudinal type of waves. This diagram is in fact showing me what do I understand by transverse and what do I mean by longitudinal type of waves. So this shows that medium is divided into alternately crest, troughs, and in case of compressions, rarefactions, one crest and trough, they will be forming together one transverse wave, one compression and one rarefaction, that will be forming one longitudinal wave. Well, let's talk about terms associated with the wave motion. Amplitude, wavelength, then we will speak about time period t, frequency n or f we denote it by, and velocity or speed of wave. What exactly is meant by amplitude? Then I just have a look at the diagram of transverse wave, and I find that the particles were vibrating some distance from their mean position. So whatever is the maximum displacement particle travels from its mean position, it will be called as the amplitude. Amplitude is the maximum displacement. Basically, we all have to remember that. It's denoted by capital A. We will take it as a symbol for our convenience, and SI unit of amplitude is meter because it's actually a displacement. Whereas if I talk about what is meant by wavelength, wavelength is in fact the length of one complete wave. So it's the distance between two successive crests or two successive troughs or two successive points having mean positions of the same phase. Ultimately, it is not only about compressions or two successive rarefactions, but it's all about the distance between the two successive particles of wave in the same phase. It's denoted by symbol lambda, and its SI unit is going to be meter. So in this diagram, I find that if I have, this is one particle and this is the other particle, they are having crest to crest, this will be called as one complete wavelength. Or this crest to this trough, it is half of the wavelength. Now this compression center to this compression center will be one complete wavelength as well. Now what exactly is meant by time period? Then time period is the time taken by any particle to complete one oscillation. Now what we need to understand is that by the time, in case of wave oscillations, particle is completing one oscillation, in that same time one complete transverse or even longitudinal wave has passed through that particular point. So in the same time in which particle completes one oscillation, one complete wave also is formed and one complete wave also has passed through that particular point ahead in the given medium. So we can define time period in three different ways as shown here. It's the time taken by particle to complete one oscillation, or it's the time taken for the formation of one complete wave, or it's the time taken by one complete wave to pass through a given point. Now it's denoted by capital T, time period, and its SI unit is second. Whereas what exactly do we mean by frequency is how frequently particles are oscillating, or a particle in a medium is oscillating. So it's the number of oscillations performed by a particle in unit time. Like we have defined time period in three different waves. Similarly, we can also define frequency in three different waves. One in terms of particles oscillation, the other is in terms of waves production or passing ahead through a given point. So you can also define frequency as the number of waves produced in 1 second, or it can even be defined as the number of waves passing ahead through a given point in 1 second. Now n, or that f, frequency is 1 upon capital T, SI unit is per second. In terms of oscillations, it will be oscillations per second, or the best unit which we actually use is hertz. If you assume the particles to perform circular motion, in case of circular motion, particle performs revolutions. In that case, it can be in terms of RPS, called as revolutions per second, whereas most popular term we are using is RPS. So whenever any quantity is expressed in RPM, we all have to understand it's actually the frequency of revolution. Now we'll come to what is meant by velocity of wave. The distance traveled, or the speed of wave, it's the distance traveled by wave in 1 second. Now in time t, if the distance covered is one complete wavelength lambda, it's of course key, if you allow time equal to one complete time period, one wave has passed ahead. So the distance covered is lambda. So in that formula, if I substitute v is equal to distance upon time, if I substitute that, you find that v is equal to, it is lambda upon capital T, but 1 upon capital T can be written as n, and therefore I get v is equal to n lambda is the formula. This formula, please keep in mind that this equation v is equal to n lambda is correct for any type of wave. Let the waves be transverse, let the waves be longitudinal, or let the waves be electromagnetic. For every kind of wave, this formula holds true, that v is equal to n lambda. Of course, when you talk about light waves, instead of velocity, general symbol of representation for speed is c. Frequency is either written as n or is written by nu. Wavelength, of course, is denoted by lambda. So in case of light waves, we can write that equation as c is equal to nu lambda. That is how you can write that. So this equation gives you speed of the wave, whereas it doesn't give you, this is very important aspect for us to understand, that this equation does not give us the velocity of particles. It is going to give you the speed of the wave, because each and every particle of the wave is performing, or of the medium is performing SHM, simple harmonic motion. And for simple harmonic motion, all those particles which are at the mean position will have maximum velocity, and all those who are at the extreme position, they will be having zero velocity. So in that case, the speed of particles, or the velocity of particles, is going to change at every instant of time. So for that you will have to use different equation of this velocity of SHM, whereas this v is equal to n lambda is actually giving you what is the speed of the wave. So I think that is enough in the first session of this. In the next video we will talk about what is meant by simple harmonic progressive wave and the expressions for simple harmonic progressive wave. Thank you very much.